Hey everyone, and welcome again to the stack problem section. On this lesson, we are going to solve the problem 3. So, this problem 3 says, given a vector of integers, we need to find the previous smaller element for every element in the vector. The previous smaller element of the given number x is defined as to be the first smaller number to the left of this element x in this vector. If the previous smaller element does not exist, then we will consider it to be minus 1. So let's study some examples to visualize the idea. We have this vector here. The size of this vector is 7, right? We have 7 elements. So what we need to do is, for each element, we need to find the previous element on the left that is smaller. So for 2, there's no element smaller than 2 on the left because 2 is the first element, so we print minus 1. So this minus 1 is a cause of this 2. Then we go to 5. Is there any smaller element to the left of 5? And we need to print the first one. Well, the answer is yes, 2 is smaller than 5, so we print 2. Then we go to 3. So the same idea, we need to go to the left and find the first one that is smaller than 3. When we start going, we first find the number 5. This is the first number that we find. However, 5 is not smaller than 3, right? So we keep going, and we find here 2. 2 is smaller than 3, so we print 2. 2 is the first smaller element, smaller than 3 on the left. We now are at 7, and so we keep going to the left, and we find here that the first smaller element to 7 is 3. Keep in mind that all these 3 elements, 2, 5, and 3, are smaller than 7, but we need to pick the first one, right? So we pick 3. That's why here we print 3. When we go to 8, we find that the first smaller on the left is 7, so we print 7. When we here are at 1, we see that there's no smaller element than 1 on the left, so we print minus 1. And then when we reach 9, again, the first smaller element is the first one that we see here on the left, which is 1, so that we print 1. So in other words, for each element in the vector, we need to find a given element with an index less than the index that we are studying, so it is on the left, and also the value of this index should be as high as possible. This means to be as right as possible, being on the left of this element, so the first one to appear. That's why here, when we are at 7, we see that all these 3 are smaller, but we need to pick the index j that is as high as possible. We have here j equal to 0 for 2, j equal to 1 for 5, and j equal to 2 for 3. So what is the maximum of these 3? It is here the index 2. So that's why we pick here the value 3, right? We always need to pick, and we want to pick the index that is as maximum as possible. That's why here we're saying that we're picking the first smaller element that appears going to the left. The first example, it is very easy to see, and the second one is analogous. It is the same idea, right? We start at 5, minus 1, there's no element smaller. With 7, we just pick 5. With 4, there's no element, so minus 1. With 9, we just pick 4. With 8, the first one is 4, so we pick 4, and with 10 we pick this value 8. Keep in mind also that the output, the vector on the output, must be of the same size of the input vector, right? Here the size is 7, so the output is also 7. Here the output is 6, and also the input is 6. So the input size is 6, and so is the output, right? We always maintain the same size because we do this for each element in the vector. Very well, once we have introduced this problem, let's start the resolution of this problem. We create a new C++ file. We're using here Visual Studio. You can use any code environment that you're used to. First of all, to work with the input and output, let's include the input and output library of C++. Also, we are going to use vectors, right? And since this is a problem about the stack section, we are also going to use the stack data structure. So we include here this stack library. Now we are going to define a procedure that, given a vector, it will find the previous smaller element for every element in this vector. So this is going to be a procedure void. It's not going to return anything. The name, let's just say find previous smaller. The input is going to be given a vector of integers v. Keep in mind that we are passing this vector with reference, because this is a vector, right? We don't want to make a local copy of that, we just pass it as a reference. And then also we are going to pass the size of this vector, okay? This is optional because you can infer the size of this vector once you are inside this procedure. You can just say n is equal to the size, but we are going to pass it as well. Also keep in mind and remind here that we need to use the namespace for the standard libraries. So we just use here namespace std. And now instead of needing to write std vector each time, we can just write vector. So let's comment what this method and what this procedure is going to do. So this procedure is going to find the previous smaller element for every element inside this vector v. And we are going to do this using stacks. So we are going to explain this step by step. Given an initial vector, let's just imagine that this is our vector, okay? The first thing that we are going to do is to create an empty stack. So here we create our empty stack. This is our stack S. So let's do this in the code, create an empty stack, and we can do as easy as we just write stack, then the name of the data type that we are going to use it for. So we are going to store integers inside this stack because we have a vector of integers, right? Let's just name this stack S. Here we write the name of this stack. With this we create an empty stack. And now for each element inside this vector, because we want to treat all of them, we are going to apply this algorithm. So let's do here a for loop so that we can apply this for each element in this vector. Okay, keep in mind that this is just a for loop that traverses all the elements in the vector. We have a total number of n elements, so from 0 to n minus 1. This is going to be the indices, right, of this vector. So we're basically going to loop element by element. And now we are going to apply this algorithm for each element in this vector. The first thing that we are going to do is we are going to do a loop while the stack is not empty. We can just write this, not empty, or we can just use the exclamation symbol. In C++, when you write this exclamation, this means the negation of this condition, right? So while the stack is not empty, so here this is going to loop until the stack is empty, right? What we're going to do is to check for the previous smaller element, basically to find that element on the left, the first one that is smaller to this element. But before going on to this case here, let's just consider the case that if the stack is empty, which is precisely our initial case here, right? The stack is empty. So here, if the stack S is empty, what is going to happen and what does this mean? Well, this means that all elements to the left of this element are greater. So there's no way we can find that previous smaller element. So in this case, we are just going to print -1. So here we just print -1 and an end of line. And also we will print, instead of end of line, a space, right? A blank. Well, this is precisely what happens first here in the initial case, and also may happen when we are on a given case that there is no element smaller on the left, right? So here imagine we start. Is the stack empty? Initially, yes it is. So for this two, we are going to print -1, right? So let's here start printing the output. Very well. We print -1. Good. Very well. So after printing the smaller element, that we will do it now, or printing -1, either case, okay, either way, we are going to push here the current element onto the stack. So we are going to push current element into the stack. So we can do this as easy as just write the name of the stack, push, and here the current element. So we write v because this is the name of the vector, and then the index I. We write I. This is the current element. Right, so following step by step, what we need to do now in here is to push the current element. And the current element that we're dealing with now is 2, the first one. So here we just push 2. Very well. Now, as we increment this value of the index and we go now to the next iteration, now when we come to the next iteration, what is going to happen? Well, this while loop we are going to enter inside because now the stack is not empty. Keep in mind that we have onto the stack this element 2, so the stack is not empty. And keep in mind that now the current element is with index I equal to 1. And this current element with the index I equal to 1 is this one, right here. I is equal to 1, so we are now working with the number 5. We need to find the previous element that is smaller to 5. In this case, we need to return 2. So let's see how we can do that. Well, remember that on the top of the stack, here on top of the stack, we have the element 2, and this is precisely the previous element, right? The previous current element that we were dealing on the previous case. So now we check if the stack's top element, which is in our case now 2, is less, right, or smaller than the current element, which is now in our case 5, then this stack top element 2 is the previous smaller element. So it is the element that we want. So here we just check if the top element of the stack is smaller than the current element, which is now vi, right? Then this means that this is the element that we want, the s top. So we can just here print cout s top, a blank line, and also since we want to leave this this while loop, we can here just do a break. This because maybe we have more than only one element on the stack, right? And if we don't break here, then we are going to print lots of these 2's, and we only want to print it one time. Okay, we are only going to do this one time for each element. So this means if this condition is true, it means that we have found the smaller element on the left, and so this current element 5, okay, the current element that we are dealing now, is already closed. Okay, it is already solved. We break to go to the next element. So we leave this while loop. Once we leave this while loop, we will come here. We know that this is false because the stack is not empty. We have 2 onto the stack, so the stack is not empty. And we are just going to push here the current element onto the stack, which is now 5. So now the next thing to do is to push 5 onto the stack, right? So here we just push the number 5, and keep in mind that we also need to print here the value 2. We are printing here 2, remember? From this condition here, we just print 2, which is the top. Very well, now we go to the next iteration, right? Now the iteration here, the index is 2, so the current element is this element 3 now, with the index equal to 3. Well, in this case, equal to 2, right? This is the element that we're dealing with, the value 3. So now 3 is the current element. The first thing that we will do is to check if the stack is empty. The stack is not empty, right? So if the stack is not empty, we will come here and we will check, all right, is the top element, which is in our case now 5, right? The top element is 5. Is this top element more than the current element 3? The answer is no. So this condition here is false. We are not going to come here. So now we need to consider the otherwise case. So this else is when the top element is greater or equal to the current element. So it is not smaller. This is the otherwise case. If this happens, then keep in mind that since we already checked the number 5, we need to go more to the left to check the number 2, right? So to do this, we need to pop this element from the stack. So here we just pop the 5, and now again we check the same thing. We check if the top element that now is 2 is smaller than 3. The answer is yes, so we will print 2 here. So we need to pop this top element, okay? Again, we only pop this top element if this condition is false. So here we just pop the top element. Again, we are only popping this top element, right? If the stack top element is, if it is greater or equal to the current element. Very well, once we pop this, again, the stack is not empty yet because now we have onto the stack the number 2 yet. We are, right? We still have here the value 2 onto the stack. The 5 is out. We have popped it from to the stack. And now since here, this is the top element, we are going to do the same condition. Is the value 2 smaller than the current element, in our case 3? And the answer is yes. So we are going to print the top element, which is 2. So here we just come here and we print the element 2 on the output, like so. So as we can see, we begin to have here the same initial output sequence, which is precisely the solution. And you can verify, okay, that for each element, if you do this algorithm step by step for everyone, you'll have at the end this same solution, okay? And this is the algorithm that, given a vector v, given a size of the vector, this procedure is going to print the output sequence, okay? It is going to find the previous small element for every element in this vector. Very well, so now let's verify that this is working right for all the inputs that we have, right? So here let's define our main function, our main procedure. let's define a vector v, for instance, to be the same one, this one in here, 2, 5, 3, 7, 8, 1, 9, which is precisely this one that we've been working on. Remember, to define a vector, we open with braces. Here, 2, 5, 3, 7, 8, 1, 9. We also separate the elements by commas. The size of this vector is 7. We can just define it as the size with the size method of vectors. And now, to simply write the solution, we apply this procedure, the find previous element, or find previous smaller, to the vector v with size n, like so. So let's run this program and verify that the solution is correct. So let's run this code. We go to debug, start debugging, and we can see here on the output that we have precisely the same solution as on the problem statement. Also, let's verify this second example that we obtained the same solution. So we change this vector to be 5, 7, 4, 9, 8, 10. And now again, we run this program. We can just press F5 as well. And we can see here that on the output, we have the same sequence as on the problem statement. We have -1, 5, -1, 4, 4, 8. So we verify that this program is working right. We remember the student that you can download all the solution to this program, all the code, as well as the problem statement on the downloadable documents of this lesson.